So here's an update on my control system design and build. So building two control units that are almost identical. One will sit at the rear of the car, the other will sit at the front, and they will communicate via CAN bus to a master control module. But these guys have all the hardware to do the heavy lifting. The master control module will just be essentially a processor. So these guys, at the heart of the unit is a Arduino Mega. The nice thing about this is it's got 16 0 to 5 volt analog inputs with 10-bit resolution. So they can handle most any input from a standard automotive 0 to 5 volt sensor. It also has a lot of pins that can handle digital inputs and outputs with PWM control on many of them. So those will be useful for things like controlling the boost control solenoid. So I've got an intermediate board. This is just a prototype board shield that will just plugs right on top of this. And this is where the majority of the low voltage sensor wires will be soldered directly to. I'll have my voltage divider resistors in here for any of the temperature, NTC or NTC style temperature sensors. And then on top of this board plugs this board, so it'll be a 3-layer stack up. And this board here is a CAN bus shield from Seed Studio. So this allows the Arduino Mega to both send and receive data on via CAN bus. So all those will stack together. There will be some hardware, but mostly wires soldered to this. In the box, the control box, will also be this relay board. So it's got 4 about 10 amp capable electromechanical relays. So these are good for switching higher current devices. For example, my oil scavenge pump, which pulls about 3 amps, so nothing real serious, but it allows me to keep that electrically isolated from the low voltage and more sensitive control board. And the control board just turns it on and off via these little pins here, pulling them high or low. I'll also have several of these guys, which are just MOSFET boards. So these again allow higher current switching, but these can handle really high frequency. So for example, the PWM control, again, of the boost control solenoid, the Arduino can turn on and off the signal to this guy really fast, and these MOSFETs can turn on and off the power switching very fast. So it can PWM drive higher current motors and switches and whatnot via PWM nicely. So this guy's H-bridge controller, bidirectional. So this will be used for the bypass valve, which is a repurposed electronic throttle body. So this can handle about 17 amps without a heatsink. These can handle about 10 amps without a heatsink. So very capable units there. This guy's a 4-channel op amp. So what this will allow me to do is to read any of the 0 to 5 volt signals that the vehicle already has on board without having any influence on that signal and how let's say the ECM reads that signal. So I can, for example, the MAF sensor, I can wire the 0 to 5 volt output from the MAF sensor into this op amp. And on a different pin, the Arduino can read an equivalent voltage. So depending on how I set this thing up, the input from the MAF sensor will be duplicated on a different pin, and the Arduino Mega can read that. So I'll have direct reading of the MAF sensor, and I won't have to handle any communication with the OE ECM and take up bandwidth on the CAN bus for that. So this will be a more direct measurement. I've got this module, which does a great job at handling the turbo speed sensor output. So it just translates that output into a 0 to 5 volt signal, again, that the Mega can handle very easily for turbo speed. I've got this module, which is a Type K thermocouple amplifier. So through this thermocouple plug, thermocouple will be wired into this guy, plug into the box via this plug here. And this will communicate with the Arduino and be able to, it has about a 0.25 degree resolution, so way more resolution than I'll need, but I can, again, read directly from a Type K thermocouple, so EGTs, again, right to the Arduino Mega. One board that is missing from here, I'm still waiting for them to show up, is a wideband controller board from 14.7. So they call it a Spartan 2 OE or OEM. So here's a spec sheet that I just copied some screenshots from. And so it's just a small board. You can wire in a LSU 4.2, and then it outputs a 0 to 5 volt signal. There's another variant of it, but I decided to use this one. So again, 0 to 5 volt that the Arduino will read. So EGT reading directly, wideband controller reading directly, CAN bus, solid state or electromechanical relays, MOSFETs, H-bridge controller, all of that turbo speed sensor capability, all that will be integrated into one box. I've chosen these connectors to connect all of those wires to the box. So these are Molex connectors. I don't remember what series they are, but this is a 24 pin. So this will handle all of the low voltage, low current sensor wires and channels. And this is a 18 pin, and this will handle the higher current. Each of these pins is capable of 10 amps continuous, and I think 15 amps for a shorter period of time, but these pins will easily handle the current in and out from this unit. So this is the first attempt at pulling together some of those components on a single board. So I've got 1, 2, 3, 4 of the MOSFET boards, one of the H-bridge boards, and then I've got a 0 to 5 volt, a 5 volt voltage power supply. So the red and blacks are 12 volt in, so 12 volt into that guy. And through the board, it provides a nice clean 0 to 5 volt or 5 volts power supply for like all the sensors and the Arduino. Same thing, the H-bridge receives 12 volts from the car, and then depending on how I drive it with the Arduino, it'll output polarity either direction to drive the motor as needed. So I'm trying to keep things straight. I've got rear or front Arduino kind of spelled out here, rear Arduino spelled out here in terms of analog inputs, outputs, all the different hardware that I need to be sure that the boards include. And that way I can be sure that my single board design or my single controller design includes all of the capability required at both ends of the car. And then I've got just this Excel sheet that's got lots of tabs. But right now where I'm at is I'm trying to break up. I've got the 24 pin connector listed here and the 18 pin connector here. And then you see that's the thermocouple 2-pin connector. So listing out what they do, what type of signal it is, where the signal comes from, or power in or out, how all that's handled. So I'm slowly trying to work my way through so that when I design my box and wire all this in, I can be sure all my wires are going to the right spot, both on the board, the intermediate board, and this guy, and they're pinned in to the right connector. And the car is already wired, so all I have to do now is, just like this, the car has a bundle of wires at the back and already a harness at the front that I've made, and I just have to terminate at these connectors and pin those correctly with all of the functionality, and then program the board at each end. So I have most of that worked out because I've got a control unit in the vehicle already doing most of this. And so I've got a good bit of confidence there. So really, my biggest concern is just making sure that all of this is going to work together. And so, yep, that's what's happening. Wonder if that was confusing. Hope not.